Okay, so now we're on to, let's see, okay, so everything's there. So now we're on to number 7. So number 7 is kind of a doozy. So it asks us to find the volumetric flow rate. But now we're told that we actually have 2 of these, kind of 2. So they're the vertical ones, so our V is no longer 0, okay? So all we get out of this is that we now know our pressure difference, okay? And so we have Bernoulli's like last time, and now, oh look, I'm going to be lazy, I'm just going to sit down. So now our, let's see, our pressure heads, sorry, our elevation heads are going to be 0 still. So this guy and this guy is still canceled, and so now we come down to the fact that we have V1 squared over 2 plus P1 rho equal to V2 squared over 2 plus P2. Okay. But because we don't know V1 and V2, and basically Q, we actually need to introduce another equation. And so that's going to be conservation of mass. So as you see in the next line, we express both V1 and V2 in terms of Q and A1 and A2. And because we basically know A1 and A2, I tell you guys I know the diameter, and it's a tube, you know, and you know the diameter for both sides. You know, one I've called little d here, and the other I've called big D. And so A1 is going to be little d squared times by pi over 4, and A2 is going to be big D squared times by pi over 4. And I didn't bother to write it, but you would know that. So A1 and A2 are knowns. And so Q is now our unknown. So what I'm now going to do is I'm going to bring all the velocities on one side, because I'm going to express everything in terms of a Q. And I can express V1 and V2 both in terms of a Q. So that's exactly what I do. I bring all the V's on one side, I bring all the P2s and P1s on the other side, here. And because I'm treating delta H as a known, you know, so basically I give you guys the pressure difference. By giving you guys this delta H, I've given you the pressure difference, the kink of pressure. I haven't given you the individual pressures, you don't have that information, but I've given you the kink. And so, you know from hydrostatics, delta H times rho G, the rho's cancel, and so you're left with delta H times G. And that's equal to V1 squared minus V2 squared all over 2. Now if we go over to the rest of the board, okay, didn't do this very well. Okay, sorry, it's a little cramped. We're behind my desk. Okay, so, let's see. There it is, okay. So now what we've done is we've expressed, so it's exactly what we got out of Bernoulli, that first line that you're seeing here. Let's see if I could do this. Okay, so that first line, right there, that's going to be what we got out of Bernoulli. Okay, but now we want to express it in terms of, we want to express V1 and V2 in terms of the Q and the A's. So what we do is we sub in for the fact that way over there, we express the Q's, the velocities in terms of Q and A. See, right below my finger, right there. Okay, so we plug that in, and now we're able to find Q. Okay, so that's problem number 7.